With BizTimes Milwaukee. I'm here with Tom at the brand new CalStar brick factory in Caledonia. Tom, talk to us a little bit about this facility, its size, and what you're doing here, and how it's unique to the brick industry and the construction industry in Milwaukee.
Sure, thanks, Eric. This is the first plant of its kind in the world. We're using fly ash, re-energy power plant, to make bricks and pavers that use dramatically less energy and therefore produce much less greenhouse gas emissions in their production than the products they replace. The products they replace are clay pavers and clay bricks and concrete pavers, and all of those a lot of people don't realize, but they're very energy intensive in their manufacturing. So we're taking all that energy out and using a greener product to the market.
Now, Tom, one of the things I think is really interesting is that you're using the fly ash from the Oak Creek coal power plant, which is just up the road from here, which normally would be waste, and you're turning that into a tangible product that can be used to build new structures.
Fly ash is a really interesting material. In fact, Wisconsin is a leader in the country and in the world in its reuse and recycling of fly ash. A lot of people don't realize this either, that fly ash, if you look at an average piece of concrete in the ground or your house foundation, on average in the US about 15% of the cement in that concrete mix is replaced with fly ash. And so fly ash is used very broadly in construction materials already. With that said, we produce in the US about 75 million tons of fly ash a year.
That's a lot.
And only about 15 million tons is used in that application as a cement substitute in concrete. So there's lots and lots of excess available.
And we're standing here in front of a big drying apparatus. Talk to me about how this system works and how it's different, how you save a lot of, you're not only using a green material in the fly ash that you're building the bricks out of, but you're using a lot less energy to produce and to dry out and to solidify these bricks than a typical sort of system.
So what you'd see in a typical clay brick plant is a big mine next to the plant where clay gets mined out of the ground, and then it gets taken to the plant and gets formed into clay, just like you might imagine your Play-Doh fun factory, right?
Sure.
It basically gets extruded into shapes, into brick shapes, and then loaded onto little rail cars that roll through what's called a tunnel kiln. And a tunnel kiln for clay bricks typically be maybe 100 feet long, and it'll run at 2,000 degrees all day, every day.
That's a lot of energy.
Just natural gas, or coal or pet coke, firing that kiln 365 days a year to run bricks through.
Okay.
So that gives you kind of a snapshot of the energy intensity of clay bricks.
Sure.
What you see behind you here is a curing chamber.
Okay.
So think about an order of magnitude less temperature,
right,
and some moisture.
Okay.
And we're
it's
able
actually
to,
making steam.
That's right. We're able to, with a much lower temperature and basically with some moisture, cure these products and achieve the same physical properties that are delivered by clay bricks.
So with a clay, comparing these bricks with a clay brick, you've got the same hardness, the same energy efficiency, I guess the same R factor?
That's right. The same, sometimes called thermal mass in the building. And the same compressive strength, same durability, etc. So we meet the same ASTM standards that the clay brick industry puts forward to test their products.
Right.